Hey everyone, so in the last video, we looked at distinguishing between prime and composite numbers. We spent quite a bit of time defining these, and in this video, we're just going to have a look at a pretty interesting result that comes about when we look at composite numbers. And this has to do with factor trees here. Now, what are factors? Well, factors are just two numbers that, when multiplied together, give us the number of choice. So let's say we looked at the number 36. And we are going to make a factor tree out of this. So factor trees are really just taking a number and we are just kind of breaking it up into its factors. And this is going to kind of branch out like a tree would. We can think of the 36 as at the root of our tree, and it's going to branch out as we look at all of the factors of this number. So in constructing this, let's just look at two numbers that make up 36, or two numbers that multiply together to give us 36. Well, I'm going to pick, let's say, 6 and 6. That's a pretty simple one. So when I multiply 6 by 6, it gives us 36. That's how our factor tree works. Now, I can take this a little bit further because I want to just find, when I find these factors, I want to see if they have any factors themselves, because 36 was a composite number. It's composed of two other numbers that multiply. But these two sixes are also composite numbers. Two numbers that aren't just 1 and 6 multiply to give us 6. Now, the two that we have are 3 and 2. And that's going to be the same case for this one. 3 and 2. Now, let's look at the numbers that we're pretty much left with, because we broke down a composite number into a product of another two composite numbers. And then when we broke these composite numbers down one more time, all the numbers we were left with are prime numbers. So that's a pretty interesting case. Now, noting these four numbers, we have two 3s and two 2s. Let's see if this would have changed if we picked two other factors of 36. So if I were to rub all this out, let's take another two factors. Well, we can do 12 and 3. 12 and 3 multiply together to give us 36. 3 is a prime number, so it's going to be redundant to kind of keep branching out because we can just keep going, and we're not really going to get anywhere because we're still going to tell each other the same information. This is a prime number, so we can leave it. Now, we're going to focus on the composite number here. So if I break up 12, well, what are two factors of 12? Well, I have a 6 and I have a 2. I also could have done 3 and 4, but you'll see that no matter which way we approach this, we will always get the same numbers. Now, hopefully we have the hang of this by now, so I'm going to go ahead and do this one. I have 3 and 2. Now, let's zoom out. Let's look at the bigger picture here. So, once again, we broke up 36, and in the end, we were left with the same prime numbers, which will all multiply by one another to give us 36. Once again, we have two 3s and two 2s. So it would have been the same if we took, say, 9 and 4 as well, because the 4 would have gotten broken up into two 2s, the 9 would have gotten broken up into three 3s. So no matter which way we go, we always get these same numbers. So that's a curious case. And one thing we observed was no matter which way we go, we always get the same numbers that multiply to give us 36. The same prime numbers, I should say. And the second fact is these are prime. So that's an important thing to consider. But Let's look at one more example. Let's take another number. Zoom back in here. And you can try this with any composite number, because the essentially the rule or the observation we see, and the observation that you'll see when you work through some numbers of your own choice, we will start to see certain patterns emerging. That is the crux of this video here. So let's take another number. Let's go, what's an interesting one we could do? Well, let's just go, let's go 48. This is another number that we can break up a variety of different ways. So the first way is, well, some factors of 48. We can go 24 and 2, but that's a bit boring. Let's do maybe 12 and 4. 12 and 4. And we notice composite number can be broken down as a product of two other numbers. This is the definition of a composite number. And once again, we're left with two composite numbers here, which means that two numbers that are not one or that number will multiply to give us 12 and 4. Now, starting with 4, that's sort of the easier case. But 4, we get from multiplying 2 by 2. Now, looking at 12 here, well, we did 6 and 2 last time. Let's do 3 and 4 as factors of this. We have a 3 and we have a 4. And we're left with prime, 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 composite again. So breaking this down one more time, we get 2 2s multiplying to give us 4. Once again, we've kind of worked our way down this factor tree. And once again, we end up with prime numbers. And I'm not going to do it in this video because it'll take up too much time. You can do it in your own time. But if we say picked 24 and 2 here, or 6 and 8, I think, yeah, 6 by 8 as factors, we would have ended up with the same prime numbers here. So what we've essentially found is that, well, 2 times 2 times 3 times 2 times 2 will give us 48. What we found here is called the prime factorization of this number, and 36 in the previous example. And this essentially works off the theory that a composite number, any composite number, can be written as a product of all of its prime factors. So when we break down a composite number in the same way we've done here, first branching out here, then continuing down again, we can break up any composite number into a product of primes. And this is how we can explore this theory, by drawing these factor trees. Now, I purposely picked quite small numbers because for time purposes, but you can have a go with a number of different examples. You can go into the hundreds, you can go into the thousands if you have the time to play around with numbers like this, but you can get some really interesting prime factorization, these prime factor trees happening. And you will find that the two things we talked about in this video is that we always end up with the same numbers, the same prime factors for our chosen number, no matter which route we sort of take. We saw that in the previous example. And we can break down any composite number into a product of its prime factors here. Thanks so much, guys. I'll see you next time.